Hi, my name is Hamid Fatih. Welcome to my channel. Today we are going to whisper, but not in the way you might think. I'm talking about OpenAI's Whisper, a powerful speech to text system and its C++ counterpart, whisper.cpp. OpenAI Whisper is an open source automatic speech recognition ASR system built in Python. It can convert spoken audio like podcast, phone calls, or YouTube videos into text with impressive accuracy. Whisper CPP, created by Georgy Gerganov, is a C++ implementation of the original Whisper model. It's optimized to run efficiently on nearly any device, even without powerful hardware. The goal of this course is to build a Web API endpoint where you can send audio and receive transcribed text in return by using whisper.cpp because it's fast and efficient. There are two main approaches we will explore. Using whisper.net, a library that can call whisper.cpp, or calling directly a compiled version of whisper-cli. Each method has its own benefit, and I will walk you through both. About good things for whisper-cli, the first thing is showing better results because it's up to date, because it has latest features and fixes. The next thing is more accurate timestamps in the results. Also, Whisper CLI supports more input formats like MP3. But Whisper.net, the library we will use, support only WAV file. And if you need to use MP3, for example, you have to use an audio to convert it. Whisper CLI supports also more output formats like SRT, VTT, and LRC. But for Whisper.net, you need custom formatting based on a segment data class. I will show you how you can write SRT exporter for it. But good things about this library, because it's calling the native libraries, the native C++ implementations, it's 2-3 times faster than calling Whisper CLI. The other things about using Whisper.net library, it is more natural and integrated for C# developers. And also it doesn't need C++ compilation process. For Whisper CLI, we need to clone the source code and compile it first. I will show you how this will possible. This is the example of Hello song by Adele as a WAV file I sent to both implementations. Whisper CLI shows this result. And as you can see, it's really accurate, the timestamp and the other things. And in here, when I'm using whisper.net, it's just a raw format of the result. You can see the information here. And honestly, it's different. For example, if you check the lyric of the hello, you can see it's like to meet. But in this version, whisper.net is using, it's detected as a like to me. So using Whisper CLI has own benefits, but it has also some challenges. But let me first show you the C++ compilation process of the Whisper CLI and the whole library. Then we will back. It's time to compile Whisper C++ project. For this purpose, first we need to have Git installed on our machine. So you can download Git based on your operation system and make sure it's up and running. You just need to call it here, for example. As you can see, it's detected. So whenever you have the Git, it's time to clone the Whisper-C++ repository. So git clone and the address of the repository, we can just download it. I'm downloaded it under a Whisper folder in here, the empty folder. And let's see. By downloading, we should go inside the Whisper C++ folder. And in here, we need to download first the model we want, the AI model we want to use in process of extracting a text from an audio. So we will go to models folder, and we have to execute this command, download ggml model, and the model is base.en here. You can see in the website of Whisper C++, the models are available. At this moment, I'm using the base.en, but you can use the others, for example, large version 3 turbo. So bigger size and better results. So let's back to the command line and execute it. Whenever it's downloaded, you can find it in here under models. And as you can see, gml-base.en.bin is here. We will use it in the process of using the Whisper CLI. We should pass it as a parameter. So I will back to command line, and we need to build the source code. For building the source code, we need to have CMake. So you can go to the cmake.org, and based on your operation system, you can install it. Whenever you did it, you should be able to call cmake in the command line. And as you can see, it's detected. Whenever you have it, it's time to build. So I need to back one folder, and in this whisper.cpp, I'm ready to run the command. The command for build is cmake b build. But I have an NVIDIA GPU, so I want to use CUDA for better processing and execution quicker. So if you already have NVIDIA GPU, I suggest you to compile based on the CUDA. For this purpose, you need to go to the NVIDIA website and download CUDA toolkit based on your operation system. Whenever you did this, you should see NVCC is available or not. As you can see, I got the message, it's detected. So instead of cmake-b build, now we can use one parameter more. cmake-b build ggml underline CUDA equal 1. If you have 5000 series of NVIDIA, you need this command too. CUDA architecture. You can find this information in the GitHub page of whisper.cpp. But at this moment, I will build it. Whenever it's finished, you can find build folder under whisper.cpp. Build folder is here, and these are the file we can release our executable files with them. So I should back to the terminal, and this time I will execute cmake dash dash build dash dash config release. Let's execute it. Based on your hardware and system, it takes time to create all of this. By finishing the compilation process, we have everything we need. So we can back to the whisper-cpp folder, and under build bin release, as you can see, we have everything, especially Whisper CLI. So I back to the terminal, and I go to the release. Let me clean. And now I want to test the Whisper CLI. So I will pass the hello.wave, the audio file I have. This is a song by Adele. I'm passing the model we downloaded, if you remember, ggml-base.en.bin. I'm setting an output. It should be without extension. It will be output.srt, and here I want to have srt. There are other types. You can use txt, vtt, and it's also support mp3 files. It's really great CLI. So let's execute it. As you can see, it's working very fast because of the using the CUDA. And yes, it's detected the piano music. Hello, it's me. I was wondering if after all these years you would like to meet. This is the exact lyric. So also I have the output file, as you can see, and I can open it in the Notepad++, and it's here. It's detected very well. Okay, now we have everything we want. This project contains whole of the source code, and I want to show you how these endpoints work. The first things, after the compilation, you have access to all of these files. So I have created the Whisper folder here and copy pasted the Whisper CLI and the other DLLs here. Then in the solution, I mentioned I want to copy Whisper folder to the output. This is very important things. And for the Whisper.net part, because we have two services, one with the Whisper.net library and the other one with calling directly the CLI. So you can add Whisper.net and Whisper.net runtime CUDA. As I mentioned, I have NVIDIA graphic, so I will use CUDA. But if you don't have and you want to run on CPU, you can use the other one, the runtime itself. But I suggest you, if possible, use CUDA because it's much faster. Okay. First, I want to show you some enums. We need them. The first thing is a Whisper output format. Text, VTT, SRT, and LRC. These are provided by CLI. The next thing is the languages supported by supported by Whisper library. As you can see, it's a huge, around 100. If you wonder how I found them, you can use this link to check the source code. I just created the enum with the names there and description. These descriptions are necessary to pass to the CLI to detect the right language. But by default, auto works in most of the scenarios. So we should see first the Whisper services. Whisper service is a service on top of Whisper.net. The good thing about this implementation is we don't need the downloading model process. If you remember, I showed you how to download it in the C++ compilation part. But in this implementation, we will download it automatically if it's not there. So a simple map method for GGML type, which is enum in a Whisper.net library, to the exact name of the file, model file. So we have a method for downloading the model. As you can see, I created the Whisper helper to help me on some situations. One of them is fix model name. As you know, it's always start with ggml dash and ends with .bin. So if someone didn't send and just send us a short name, we just fix it. So let's back. And after this, we should be sure about the GGML type. We check it. It's same as what we already know as a part of enums or not. Whenever we found the enum, we will continue. If the model file is not exist, we should go and download it. So there is a good thing about this library. You don't need to be worried about it. There is a downloader here, and just call it. Pass your type and then create a file and open the stream there. And I'm returning the true for good situation and false for bad one. Then we need to have another method, transcribe audio async. We need the audio file path, model file name, the language we want to translate or transcribe, and cancellation token because it's async. And again, we fix the model name if necessary. We create a factory from pass with this library, and we need to pass the language if it's set. I have an extension method here, enum extension, just for getting the description of an enum. So you can easily use it, pass it to create the processor, then we read the file and process it. We will get a segment data, and this segment data contains a start, end for the timestamp, and the content, the text. So I want to have SRT, not really a raw format, a raw text. So I need to create another class for it. So I created the convert to SRT here, and I'm reading all segments and creating a SRT output. It's not really difficult. You just need to format the time based on the SRT format, which is this, and create this specific symbol between a start and end, and append the text in the next line. So this will convert our text to SRT format, which is provided by CLI itself, and we will use it. Okay, So that's it. This is a Whisper service. We want to have exactly the same thing in for the CLI. Just the only thing you should consider, the audio file path for this implementation and this library should be WAV. If you need, for example, MP3, you should use a third-party library like an audio to convert it first. So let's see a Whisper CLI and how it works. Exactly same format, same overload. For this time, we will go for download the model. We need a model name. And we have a fixed model name, same as before. I want to create a path in a Whisper folder and put the downloaded file there. If it's already exists, we don't need to download it. But if not, we need to download it. So you can see all of the models in this URL. But for downloading, we need to use resolve and pass the model file name. Then I created the HTTP client, and I'm creating the directory of Whisper if it's not there, and then save the file. So we can download the model without a library ourselves. The next part is transcribe audio async, same as the other one. And in here also, we need to dealing with the directories. So I'm reading the Whisper CLI from the Whisper we created here. And if you remember, we set it to copy in the output. And I'm converting the enum to the exact argument Whisper CLI will accept. And afterward, I'm reading the audio file without extensions, because you should pass the file, the output file you want without extension, and define your extension based on the format argument here. I showed you in the C++ compilation in the end as an example. So we create our argument string passing the audio file path, the model path, which is downloaded, the output file path, the language with the get description, and the format we want. In here, I have a semaphore. If you're worried about the concurrency and you want to address each request just at time and disabling the concurrency, you can just define a semaphore slim, and in here you can wait for it, and in the finally you can release it. It's not necessary, but not bad to show you as a part of example. We check first Whisper CLI is available, then the model is available or not. The model will download. Then we need to use process start info to call CLI directly. So I created the process. I want to have a standard output and also a standard error here. I start the process, read them line by line, wait for end of the process. Whenever I got the exit code as a 0, it's time to read the output, the file. So I create the path here for looking and reading the file. So I just converted the Whisper output format to equivalent string and check if it exists. I'm reading it first, put it in the variable, and delete the file because we shouldn't keep this file in our hard disk. And then I return it as an output. If anything happened, I will show an error with enough information to investigate. Now we need to write our endpoints. So I will go to program because we have to work with the form file. You can change the form option to, for example, accepting 1 GB file if your audio file is really huge. Just it's not bad to mention in the example. We have two endpoints, transcribe and transcribe CLI for calling each of the services we created. Uh, transcribe, which is the endpoint you use as Whisper.net, no need or cannot use a format for the output because I told you you should create your customized format. For this example, we created a SRT exporter. So it has no format here as an input, but in this implementation, we have it. So we need to check first, this is the audio file we are sending. We have audio as a iForm file. We have model name. We have the language. By default, it's auto. We are checking them to make sure they are valid. Then I'm getting the correct language type based on the language sent by the user. We have a functionality under Whisper Helper to find and search between the whole descriptions of the enum to find it. If it's not there, will be null and I will send an error. Again, we use a fixed model name to have a solid, correct model name, and we pass it to download it if it's not there. It's provided by Whisper service. And afterward, we need to save audio temporary in our server, in our hardware. So I created a pass, a temporary pass with the GUID here, and create a file there and put the whole stream there. And afterward, I will pass it this file pass to transcribe audio async, so it can read it and pass us the output. But in the end, we have to delete the file. We don't need to keep the all input audio files in our hard. And in the end, I want to pass the result as a text. For the transcribe endpoint, if you remember, it was SRT. So I'm passing this content type and as UTF. The other endpoint is transcribe-CLI. We want to use it for calling our Whisper CLI service. This is almost the same. We have exactly same process because we implemented same model and methods. So in the end, we are just passing the format we want. The format will be one of the TXT, VTT, SRT, or LRC. And in the end, also, we need to delete the temp audio file and pass it as a response. So far, so good. So let me run the application and test it with Postman. Okay. As you can see, I'm calling the transcribe endpoint first. You should come to the body and select the form data. And for the audio, you should choose file and pass your audio. It's better you test with the .wav for both endpoints to see the differences, because if you remember, the library just support WAV by default. So I passed audio, the model, the format will be SRT and lang en. This one, the format here is not necessary. We don't need to pass it. Uh, for the language, you can set it to auto. You can just skip it because it's optional. But my audio file is in English, so I just pass it as EN. Let's send it. If we don't have the GGML base model, it will take more time to download it. But as you can see, the result is here. And it is in the correct SRT format with our exporter. And it's nice. Now let's see the CLI part. For this test, we need just call -CLI and change the endpoint with this. And all of the inputs are same. Let's call this endpoint now. Okay, now you can see the differences I mentioned before. Uh, and for example, for this one, the timestamp is a bit accurate. It's detected it's a piano music, but this just mentioned it's a music. But as I mentioned, each one has own benefits. So based on your use case, you can use one of them. If you found this video helpful, please hit the like button, subscribe for more coding tutorial, and let me know in the comments if you would like to see more. Thanks for watching, and I will see you in the next time. Goodbye.